type this in, okay, we use this right here as our x. It's next to alpha. So x squared plus 2x minus 5. Once you get that typed in, you will click the graph button, and it will sketch that for you. Does everyone's look like this? Okay? If it does not look like this, to get it to zoom out or in so that it looks like this, you will click zoom 6 and it will put it in standard view. Now, on our paper, we are going to roughly sketch that.
That's all we gotta do.
And that is what we're going to do for this one.
What's the calculator does all the work?
For that, yeah. It does most of the work for this. That's why I said every day for Unit 8 we need a calculator. Now, looking at this calculator, does it let me see everything exactly just by me glancing at it?
Uh-oh.
No. That's why it's good for sketching, but when we get more specific to the graphing, we're going to have to talk about that. Okay, so now we're going to go to the second one. So for this one, we're going to do the same thing. So what we need to do is you are going to click your y equals button again. Clear out that equation. And then you're going to type in the next one.
Can we go to the red one?
Yes, that'll just change the color it graphs it in.
Let's go.
So you do negative x squared plus 3x plus 7. Graph.
Wait.
And there we go.
Look at that DNA strand.
Well, you need to delete the other one. So make sure you delete the first equation. Yes. Okay, once you get it sketched, you're going to draw that in on your graph.
Something not making sense.
What you mean?
Take a graph and it's telling me I have an error.
Not even that.
Yeah, that's my problem.
I got that.
Yeah. So for you, the first and the second, you've got your negative in front. So you need to have a negative x squared.
That way.
Very freaky.
Yes.
So, society if X was like negative 4, would you do negative on the outside and
You related
negative
to
10 on
him?
the inside too?
Your ancestors was like.
The negative stays there,
what about
yeah.
the-
If the negative's there, it stays there. It has to stay in front if it starts with one in front. All right. Now, if A, so the number in front of x squared is positive, okay? If A is positive, the parabola opens up like a smile.
Yeah, protractor.
Yes?
Like the half circle.
I forgot what it was called, so I drew it on the whiteboard.
Oh, I hate parabolas.
All right. So if A is negative, it opens down like a frown. Okay. So one of the things that can help you remember that is if it is positive, just like whenever you're positive and happy, you smile. When you're sad and negative, you frown. Yes.
You messed it up.
No, I didn't.
Goodness, Taylor.
Every time, like, we try to do
get
this graph.
Down like.
Positive opens up like
Oh, you have it in step.
negative goes down.
All right. So now we are going to look at the second part. Okay. So an axis of symmetry. So real quick, what does it mean to be symmetric? Same on both sides. what we are going to write here, the axis of symmetry is, it's actually an imaginary line because it doesn't pop up when we graph it, but it has a place. So it is the vertical line that divides the parabola
How'd they come up with the name?
into two equal parts. What?
How did they come up with that name?
Parabola? I don't know.
Is there a guy named Brown?
Hey, how did they come up with
I don't know.
Why do you think?
You know what? I'll Google it and let you know.
I don't know.
Hey Siri, why is a parabola called a parabola?
That's some dudes.
A parabola is derived from the Greek word meaning side by side
They're Greeks.
Does that make sense?
because it's divided into two equal parts. So yeah, kind of.
Side by side.
All right, so it divides it into two equal parts.
Like a parabola.
To find the equation for that, okay, we use the equation x is equal to negative b over 2a. And I can plug whatever into b and a.
So would that be negative b divided by 2a?
Yes.
There you go.
All right, so on these little sketches we did up here, okay, I want us to go back up and we're going to draw on here that axis of symmetry. Yes. Yeah. Okay, so we are going to sketch in the line that if we were to draw a line through it, it would make both sides equal. Okay, and we're going to label that as the axis of symmetry. Okay, and we're not just going to label it for one, we are going to label it for both.
Are we just eyeballing where this line goes?
Yep, it's a sketch. It can be a little bit rough.
Because it's a little bit rough. It's a rough sketch.
All right, does anyone know what this part is called?
Which part?
It is called the vertex. Charlie, why did you say that? You're not supposed to talk.
Ask the question again.
What is this part called?
Vertex.
Thank you. You are so smart.
Not gonna wait for you to call.
Stop
Like, you
speaking
still
Chinese.
raise your hand and say it.
Stop speaking Chinese.
Y'all stop. Holy. Casey.
You're not
See,
even
Louis,
in-
why do you put up with him?
You're not even in. Oh my gosh, you should have seen us at pickleball last night.
Oh,
Casey was fried.
So, with a vertex, okay, the vertex represents a couple different things. But one way we can think about it is the place in the graph where our graph turns or changes direction. So am I increasing or decreasing right here? Decreasing. When I hit the vertex, I switch to what?
Well, it's like stop.
Increasing. It like switches and goes the other direction. So it is a turning point. The vertex is a turning point in the graph. And if the vertex is the lowest point, it is called a, what do you think?
Decreasing.
If it's the lowest point, it's called a minimum.
Minimum. I got that.
Minimum, maximum.
It is called a minimum. When it is the lowest point, it is called a minimum. Okay, I'm okay if you say min. Now, what if it's the highest point? What do you?
Maximum.
And we can write that as max. All right, so I want us to talk real quick. So when A is positive, so when it's smiling like it's happy, right? When it's positive, when it looks like this. Do I have a max or do I have a min? A min. But if it's frown and sad, I have a max. Okie dokie. So if you would like to do a little sketch of that out to the side. So when it's its lowest point, that means it looks like this. And when it's its highest point, it would look like that.
Oh, shoot. Is that on purpose?
What's on purpose?
Was them dots being right there on purpose?
No. It was just because I said sketch it there. All right. Now, we are going to do another quick sketch and talk about this problem. So we have an example here, and we're going to find the axis of symmetry and the vertex and sketch if it's going to open up or down. Okay? So, for this problem, what is A? 1. Because it is understood to be what's in front of x squared. What is B?
Hey.
No, we're on the front. What is C? 15. Okay. Now, for axis of symmetry, the formula to do that was x is equal to negative b over 2a. So I have to plug into that formula. Okay. We're going to do x is equal to negative parentheses. When you plug in, use a parentheses every single time. Otherwise, you can make sign errors. What is b? We just said it. What was it?
Hey.
Over 2 times a. What was a? And so that right there is what we got to evaluate. So we get negative a over 2, which is? So for our axis of symmetry, we get x is equal to negative 4. Okay. Now, for our vertex, if we look at this graph right here, the vertex is on the axis of symmetry. Do y'all see that? Okay, so in order for us to find our vertex, we have to use that the x value is going to be whatever our axis of symmetry is. So if I have the x and I need to find the y, what do I do to do that?
Divide. Plug it in.
Plug it in. Okay, so we are going to plug into that original equation, and we're going to do y is equal to, instead of x, I'm going to do parentheses negative 4 squared plus 8 times parentheses negative 4 plus 15. And I'm going to evaluate that with my calculator. And once we do that, what do we get?
Oh, I did something wrong with that.
Negative 1. Is that what y'all got? So that is our vertex, the point negative 4, negative 1. So now we are going to sketch this. Is this graph going to open up or down? Up, because A is positive. So we sketch that. Yes, Casey? Yeah, go ahead. Okay. And it, also on this sketch, we're going to sketch on there our axis of symmetry. And we're going to label it as x equals negative 4. And we also need to sketch on there our vertex and label that point. No flirting. Miranda, no flirting with you either. Like, you don't flirting either.
I'm not. He needs to stop.
Baylor, hands to yourself. All right. So now we're going to go ahead and flip to the next page. It's the back of this one. And we're going to look at actually graphing these, like for real, not just sketching them. Okay? So the first thing it tells us we have to find is what? Okay, so what was the formula for that? It's x equals
Negative b over
2a. Okay? And to find our vertex, okay, we plug in x to find y. And when I'm talking about x, what x specifically? The one we just found, right? We're going to take that value we just found and plug it in. And then we're going to put them in a table and graph, okay? So I want us to go ahead and talk about number 1. So first things first, I'm going to identify my A, B, and C. What is A? What is B? Does it have anything in the BX place? So if there's nothing there, what's the numerical equivalent of nothing? Okay, then C is going to equal 0. And then we just plug into our formula to find our axis of symmetry. So we do x is equal to negative b over 2a. So we get 0 divided by 2, which is 0. So our axis of symmetry is x equals 0. And that also gives us our x coordinate of our vertex. So what do I need to plug in to find my y? So we'll do y is equal to, but instead of x, I do parentheses, 0 squared. What is 0 squared?
0.
So now we have our vertex and our axis of symmetry, okay? So on our table, every single time we do this, we're going to take our vertex. Our vertex is the middle of our parabola. So we're going to put it in the middle of the table. So we're going to do 0, 0. Now, everybody grab your calculator and go and graph that function for me. So go in, clear out the last one, press y equals, and then just type in x squared in graph. Now, when we're just looking at this, can we see where every single point is exactly? It's a little difficult. So what we can click is click second graph again, and it gives us a table. Okay, that table will tell us all of the values we need. So our table has 0, 0 in the middle. So what we're going to do is we're going to enter 2 points on each side of it. So we're going to enter -1, 1, -2, 4, and then on the other side we'll do 1, 1, and 2, 4. Do y'all see that? We are just plugging that in. So we're going to do -1, 1, -2, 4, 1, 1, 2, 4. Now, if you ever don't have a calculator, you can get those numbers just by plugging them in. And then we're going to graph it. So we go over here. We go to -2, 4, -1, 2, 0, 0, or not -1, 2, -1, 1, -1, 1, and 2, 4. And then we sketch in our graph. And that is how we do that. That is how we get it a little bit more of an exact graph. Okay? And so that is what we need to do to graph it. Now, domain and range. Domain is the set of all what? X's or Y's? X's. And range is the set of all Y's. So if I look at this graph, X's go left and right. So does this graph, as it goes up, does it go straight up or does it go out? Out. And does anything stop it from going out on either side? Does it ever stop going left? Does it ever stop going right? So how do I write that? Yep. That right there will be our domain for every single quadratic unless it tells you otherwise. As long as it has those little arrows on there, that is going to be our domain. Now, range changes depending on the problem. So range goes from bottom to top, right? So does this graph go down forever? No. Where's the lowest place it actually gets to? 0. And then it goes up to where? Infinity. So infinity always gets a parentheses, but since 0 has a solid point right there, what does that mean it'll get? Bracket or parentheses? Bracket. Remember, bracket means it can equal, and it can equal 0. And so that is everything we would need to do to graph a quadratic. So let's look at number 2, and we're going to do it for number 2 as well. Actually, let's do number 3, just because I think we only really have time for one more. Okay, so for number 3, what is A? What is B? What is C? So we're going to start by finding what? So we'll do x is equal to negative b over 2a. So we have a negative, then we have our parentheses. What do I need to plug in for b? Negative 8. Over 2 times a. What do I need to plug in for a? So in the numerator, a negative and a negative make a? But in the denominator, a positive and a negative make a?
Negative.
And what is 8 divided by negative 2?
Negative 4.
Negative 4. And then we are going to plug that in to find the rest of our vertex, because that tells us x equals negative 4. And it tells us the x coordinate. So we're going to do y equals. This has a negative in front. So that negative has to stay in front. Then do a parentheses. What do I plug in for a or for x? Negative 4. Minus 8, but instead of x, we need to plug in. And then we have minus 17. Okay? When you do these, your signs can and will mess you up if you are not careful. You have to make sure that when you are plugging in these numbers, you use parentheses just like I do. Using the parentheses like this means that you can use your calculator for basically everything. Yes. But if you do not plug it in with the parentheses, this calculator can tell you the wrong answer because you have not inputted in a way that it can read it. Does that make sense? Okay. You have to use parentheses, especially when dealing with negatives. It's super important. And what does that give you when we do that? Negative what?
I got it. Oops.
And got 495.
That is not right. Let me see it. Let's see what you did. Before you change it, let me see what you did. Okay, so you forgot your negative at the very, very front. So do you see how this starts with a negative?
Yeah.
So we have to keep it there.
So you got negative 490.
All right, so did anybody else get a different number? That's not negative 400 and something. Negative 1. That is the correct answer. Okay, now I have to take that and put it on my table. Negative 4, negative 1. And now we go and graph it and go from there. So type in your equation. Type in negative x squared minus 8x minus 17 and go to the table.
Say that all again.
It's on your paper, Casey. I'm not saying it.
8x minus 17?
Yes. And it's on the board. It's in 3 places. You don't need me to say it.
Here.
So let me see what you did, Casey.
No, I didn't do anything.
I think I got it.
I don't think I can read
Why is yours in Spanish? That ain't English.
Wait, what is it? Is actually?
Put it in Chinese, give it to you.
There we go. And again, you didn't put negative.
No, I'm down here.
You gotta clear them. And then to get it to put in, you gotta put the negatives on.
Wait, does it matter which one you put it in?
Is that right?
No, it just changes color.
Yeah, I got that. She got that.
Alright.
Wait, so if you put in like Y1 and Y2, will it give you two of the same graph?
Hey, you're supposed to be getting out by
Alright. Now, we take and we input our stuff from our table. Ah, that's the wrong way.
Oh, no, go to mode. Go to mode. Shut it
Stop
down.
putting it in English. Or out of English, please.
I wasn't trying to put it out of English. I was trying to get him to this screen. Graph.
Okay, is that what y'all's table had on it as well? Hold up. I want to see the wristband.
I ain't gonna lie, I let mine at home, dog.
Then you can go.
I paid for it.
If you don't have a wristband, you can't get in.
I paid for it.
They're not going to let you in.
Just he can go tell them that he forgot his wristband. They have him on the list.
Okay.
I paid. I just forgot that.
The rest of us keep graphing that.
Hey, we gotta go meet London. Come on.
Make sure I see your wristband before you leave. Why do you look so suspicious, Keenan?
He does have a wristband, I saw it.
He does, but why did he look so suspicious? Behind my desk. I put it over there behind my chair. All right, and so our graph should look like this, okay? For this one, what is the domain? Does it ever stop going left? Does it ever stop going right? So that's negative infinity to positive infinity. Does this graph ever stop going down? So we do negative infinity. Does it stop going up? Where? -1. And we use a bracket for that. And that is how we graph quadratics from standard form. Okay, so we are done for today. Go ahead and put y'all's calculators up and your notes away, please, and thank you.